Now we're ready to install the disk drives in the system. Now in most systems you'll be installing at least two drives, one hard disk and one optical drive, probably a CD-ROM or DVD-ROM or maybe a CD burner such as a CD-RW drive. In this case I want to talk about possibly installing up to 4 drives and how they would be installed. A lot of people are confused on the master-slave relationship and also what's an optimum setting. What we call IDE drives are really called ATA drives. That is, ATA is the technical name for the interface. And ATA currently operates up to 133 megabytes per second. That is, at least that's the interface speed. That's not the true drive transfer speed. Now, to support speeds over 66 megabytes per second and over, you need a special cable with 80 conductors. I have in front of me 2 ATA cables. One is an 80 conductor cable, the other one's a 40 conductor cable. I once had somebody ask me, how do you tell the difference between an 80 conductor cable and a 40 conductor cable? Let me think. Is that a trick question? Well, count the conductors. One has 80 and the other one has 40. No, seriously, usually you can tell the difference by looking at them. The 80 conductor cable has twice as many conductors, very closely spaced together. Now what's interesting is that even though it has 80 wires in the cable, there's still only 40 holes in the connector. So when I first saw one of these, I'm like, what are the other 40 wires doing? Well, simply stated, they're providing extra grounds. For each signal, there is a ground pair that is adjacent to the signal. So what that does is it makes the 80 conductor cable more resistant to noise, more immune to other signal problems and timing issues and things like that. Now another important thing with the cable is the length. Maximum length for an IDE or ATA cable is 18 inches. Anything longer than that is in clear violation of the ATA specification, and you basically risk corrupting data on transfers. So I recommend sticking with 18-inch cables maximum. Now, an 80 conductor cable can always replace a 40 conductor cable. So in other words, even if you're running slower transfer speeds such as 33 megabytes per second, which is a slower transfer speed, or even 16 megabytes per second, you can still use the 80 conductor cable. Me personally, I don't use the 40 conductor cables at all anymore. I only use the 80s. Now, the motherboard that we're using here came with one 80 conductor cable and one 40 conductor cable. I recommend discarding the 40 conductor cable and purchasing another 80. So now I'm going to be installing 2 80 conductor cables. One is for primary ATA, the other one's for secondary ATA. The 2 interfaces on the motherboard. And then in each of these cables I can plug in 2 devices. One is the master and the other is the slave. Now to determine master and slave, with the 80 conductor cables, these use a feature called cable select. With cable select, what that means is the cable will determine which is the master and which is the slave. All you need to do is look at the connectors. The connectors that are blue, these go into the motherboard. So these are the ones that will plug into the motherboard. The connectors that are gray, which are almost always in the middle, these are going to be for the slave drive, or the second drive on each cable. And the black connectors at the end, these are the master connectors. So these will be the first device we plug into each cable. Now, normally the primary master device will be your main hard drive. So in this case, this device right here, I'm going to plug into the end of this cable. This is going to be my primary cable. So this is going to be the primary master device. Now to determine the master-slave relationship on the drive, normally that was done with jumpers on the drive themselves. Drives had a master jumper or a slave setting. They also have a third setting called cable select. If you're using the 80 conductor cables, you really should use the cable select setting on the drive, and that will allow the cable to determine which is master or slave. Basically, if you set all of your drives to cable select, then you simply plug them into the connectors, and the master-slave relationships are automatically determined. So I'm going to first make sure that every one of these drives is set to cable select. This one is by denoting the CS position for the jumper on the back here, cable select. This is going to be my primary master hard drive. Over here, this is going to be my secondary slave hard drive. It's also in the cable select position. That jumper is correct. This I'm going to use as my primary slave device. This is a DVD-ROM drive, and on the back here are the jumpers. Cable select is the correct position, and this one is correctly set. And then this is my CD burner. And this one, when I look back here, this one is currently set in a slave position, so I need to move this jumper over to cable select. I'm going to use my pair of hemostats here. And simply grab the jumper, pick it up, and put it back on the cable select position. So now this drive is set to cable select, and the cable will determine the jumper setting. Now, a lot of people are confused on how they should set up, master and slave, primary and secondary. Well, here's the deal. If you're transferring from, you can have two devices on one cable. If both devices are on the same cable, they cannot operate simultaneously. That is, they cannot transfer simultaneously. So I'm thinking, what am I going to do? I'm going to burn CDs. That's one thing I'm going to do. And in order to burn CDs, I'm going to have files on my hard drive, and I'm going to want to transfer those to my CD burner. If I put the CD burner on the same cable as the hard drive, it's going to slow that transfer down and result in, possible buffer underruns if you have one of the older drives that don't feature the buffer underrun protection. And it's just generally going to slow things down. So I want to make sure that my burner and my main hard drive are on two separate cables. Now, another thing I do is I copy CDs. I'm talking about, legitimate CDs that I purchase. I like to make backups of them. So I'm going to want my optical reader drive on a separate cable as my optical writer. So in this case, I'm going to put my DVD-ROM drive as the primary slave device. And again, my CD burner is going to be the secondary master. So if I just had one hard drive and the two optical drives, this is how they would be. Primary master is my main hard drive. Secondary master is my main, optical burner. And then primary slave will be my optical reader. Now, if I'm installing software, if I actually install it from the burner drive, it will go faster. That is, I'll be reading from this drive and transferring to my hard drive. Remember, transferring from one cable to the other works faster than transferring from one device to the other on the same cable. Now, that sounds strange, but that's the way it works. All right, now, if I was going to add a fourth device, which would be a second hard drive, I would add that as the secondary slave device plugged in here. So that's how, if I was going to install 4 drives, that's how it should be done. All of them set to cable select because I'm using 2 80 conductor cables. Okay, well, in the actual system here, I'm just going to install 2 drives. I'm going to install 1 hard drive and 1 CD-RW. I'm going to set the other devices off to the side for now. And I'll only need, I'm still going to use 2 cables because each one's going to be on a separate cable, and I'll have the slave connectors basically as empty, not being used.